Okay, so solving rational equations or equations that have rational expressions in them is kind of, I don't want to say it's similar. It can easily be confused with adding or subtracting rational functions because both make use of a common denominator. But you need to try to remember, and we have a few more days to practice on all this, that when you have a rational equation, the only reason you would find a common denominator is to use it to get rid of all of these denominators. Whereas if you just have something, for example, let's be specific here. If you just had that, if I said to you, simplify that, that is not an equation. It's got nothing to do with what we learned yesterday. I just say simplify that. Then you would do the following. You would rewrite this as 4x over x plus 3, x minus 3, minus 5 over x plus 3. You would say your lowest common denominator is x plus 3, x minus 3. You'd then say, I need to add these things together so they have to be both over the same thing. That's why I'm finding the common denominator, so I'm going to multiply top and bottom by x minus 3. Then you would put them together. And we would get on the top 4x minus 5 times x minus 3. And you would simplify this. I guess it'll only take me a minute, so I shouldn't hand wave it away as if it's unimportant. You would multiply that negative 5 by the x. You would multiply that negative 5 by the negative 3. And get an answer of, I would probably write 15 minus x, as opposed to negative x plus 15. Over x plus 3, x minus 3. So when you're adding or subtracting, fit this all in here. When you are adding or subtracting, the idea is that you get a common denominator to keep the common denominator. Right? However, if you were asked to solve, this equation, you do the same, pretty much the same thing to start off with. You factor everything. You identify the lowest common denominator again. But your goal here when you're solving the equation is not to make everything over the same denominator. Your goal is to get rid of, and I guess I need my equals 2 here, otherwise it doesn't make sense. Your goal is to get rid of the denominators. So you end up multiplying everything by x plus 3, x minus 3. And what happens here is all of these cancel, this cancels, and you're left with 4x minus 5 times x minus 3 equals 2 times x plus 3 times x minus 3. And I'm not going to solve that equation. You would expand it all out, probably realize that it's quadratic, so zero the equation and factor it, hopefully, to get a solution. So it's important that you not confuse adding and subtracting rational expressions with solving rational equations. All that being said, does anybody have any questions you would like me to go over from this problem set? Go ahead, Janessa. 3C. Okay. All right. So I am going to rewrite this, but at the same time, and I think I see immediately why this would be a problem question. Okay. I'm going to at the same time factor that d squared plus 3d minus 4. And my thought as to why it would be a complicated question just fizzled to nothing because my thought was incorrect, I think. D plus 4 and d minus 1 is how d squared plus 3d minus 4 factors. Okay, we're good with that. And then over here we have plus 1 over d minus 1. And, you know, your lowest common denominator has to contain everything in each of the old denominators, one denominator at a time. Okay, I don't mean to imply we're going to put all this in there. It needs to contain this first denominator of d plus 4. Okay, so we put a d plus 4 there. It needs to contain this denominator of d minus 1. So we need a d minus 1. It needs to contain this middle denominator of d plus 4, d minus 1, but it already does now. In other words, if we include those two denominators, we include the third. Or if you include the middle denominator, you will automatically have the other two. And what this means is I am going to have to multiply this by d plus 4, d minus 1. I'm going to have to multiply this by d plus 4, d minus 1. And I immediately want to put this 2 minus d in brackets. It's not going to matter because the green stuff is going to cancel and we're left with 2 minus d. But my point is it's not 2 minus d times that stuff. It's 2 minus d times all that stuff. And then we do the same thing over here. So what cancels? Let's see. D plus 4 cancels here. Here, the d minus 1s also cancel here. And the d minus 1s cancel there. So we are left with d times d minus 1 is equal to 2 minus d plus d plus 4. And again, I'm doing that thing right now that I told you yesterday. The more complicated the math gets, the more I recommend you do each step twice. You know, and even then, you're not going to catch every mistake. It's a good lesson to be learned in this class, you know, in math and in life. You're never going to get everything perfect all the time. But by checking multiple times, you minimize the number of errors you're going to make. Janessa, does that look okay? Okay. So we're going to expand things out. Many of you probably would have just written d squared minus d to begin with. I would caution you against trying to do too much at once. Like I was immediately going to move stuff over at the same time. And, you know, then I might give you the impression that maybe you can go from here down to the line I'm about to write in one fell swoop. I don't think that's a good idea. You want to just take it stage at a time. So it is quadratic. I zero the equation by, wow, this is nothing here, right? That's 0d. And then I have 2 plus 4, which is 6. So I have my minus d over here. And then I have minus 6 is equal to 0. We're in the home stretch. Two numbers that multiply to give negative 6 and add to give negative 1, because it's negative 1d, would be negative 3 and positive 2. Which means according to this, we get d equals 3 and d equals negative 2. I didn't mention this in my recap from yesterday, but we do have to check for extraneous roots, right? And the only thing we really need to do here, everybody, is just check to see. It was C that we were doing. Check to see if there were any non-permissible values that affect our outcome. Meaning, did we get an answer that's non-permissible? and we got 3 and negative 2, our non-permissible values looking down in this area are d cannot equal to negative 4 or positive 1, so we're good. The two answers we got are both valid. Is that okay? Okay, perfect. Other questions? Go ahead, Seamus. 6a. So solve and round to the nearest hundredth. That phrase, round to the nearest hundredth, tells me it's probably going to be quadratic and not factorable, because then it would mean we would have to use the quadratic formula. I am simply going to have to multiply. Let me rewrite it to give myself a bit of room. I am going to have to multiply all three of these terms by b plus 5, b minus 2. That's the common denominator. And of course we're doing this, Seamus, so that we can do some canceling. Nothing cancels over here because it was over 1. And over here the b minus 2 cancels. So what do we have? We have, is it 26 or 2b? What's 26? Okay. 26 times the b is 26b. 26 times the negative 2 is negative 52. Just check my arithmetic and let me know if I make a mental error. In the last example I did, I said, you know, I'm just writing stuff down. You could expand it at the same time. That's what I'm doing here. I'm saying we have b plus 5, b minus 2 left over. So that's b squared plus 3b minus 10. And then I have 3 times b and 3 times 15. Pardon me. I have 3 times b and 3 times 5, which will give me 3 times b plus 15. It's definitely quadratic. I got a lot going on there. I really kind of regret expanding it before I wrote it down. I think I don't model good behavior there. I think it would be better maybe for your confidence if you write it down first and then expand it. Right now I'm looking at a mess of stuff and it's harder to check. But I will do so. 26b minus 52 is what I have. This should be b squared plus 3b minus 10, and that looks good. This is 3b plus 15. So I'm going to zero this equation, Seamus, by moving everything to the side where the b squared currently resides. What do I have? 6b minus 26b is negative 20b. I've taken care of the b squared. I've taken care of these and these. I need to take 15 minus 10, which is 5 on the right, and subtract 52. Well, yeah, it's not factorable. Add 52 and get 57. How was my arithmetic there, you guys? I think that looks okay. All right. I was just getting ready to say, oh, there's no sense figuring out b squared minus 4ac because we're pretty sure it's not factorable, but we need it anyway, don't we, for the quadratic formula. So b squared would be 20 squared. Again, I don't feel the need to put negative 20 in. I squared it becomes positive minus 4 times 1 times 57. 172, definitely not a perfect square. But that means that b is equal to negative b. So the b that I wrote here, I hope it's obvious. This b that I just wrote is not the b in the quadratic formula, right? The b in the quadratic formula would be negative 20. So negative b is 20. Plus or minus, did I see 172 there? Was that what it was? Over 2a. So if I wanted an exact value, I suspect 4 divides into this 43 times. So if I wanted an exact value, I would think of that as root 4 root 43, which would be 2 root 43. I would put 2 root 43 in for this radical. And then this fits in nicely with this unit. How do I cancel? I factor. I factor a 2 out of the top to cancel with the bottom. And you're going to be left with 10 plus or minus root 43. Seamus, given the fact that it said to the nearest hundredth, quite frankly, we don't need to do this or that. You could just go up top and go 20 plus the square root of 172, hit equals, and then divide by 2, and then repeat it for the minus. Does that make sense? Good. Any other questions before we get started today? Go ahead, Lynette. 3D. All right, so we're going to start off by factoring this. Does x squared plus x plus 2 factor? The only reason I'm asking is what if it factors and one of the factors is x plus 1? It doesn't, by the way. Okay, you can't factor x squared plus x plus 2 because there aren't two numbers that multiply to give 2 and add to give 1. But what if it did and one of the factors was x plus 1? Then you would be able to cancel that x plus 1 on the bottom with the x plus 1 on the top, which would make our lives a lot easier, having fewer denominators. But it doesn't. Okay, so we have, I see why this question is being asked. We have this, and then it's minus x, and it's equal to x squared minus 5 over x plus 1, x minus 1. And I hope you see, Lynette, that the common denominator will be x plus 1, x minus 1. I'm just curious, Kendra, was this your question as well? Okay. So the common denominator is x plus 1, x minus 1, which means we have to multiply every term in this equation by x plus 1, x minus 1. I didn't do a spectacular job of leaving myself enough room here, but I think you get the idea. Good? All right. So on the very last term, this will be nice, but these both cancel, and we're left with x squared minus 5. The middle term in the equation will be left with all three of those. And over here, what cancels is the x plus 1. So what are we left with? We're left with x squared plus x plus 2 multiplied by x minus 1 minus x times x plus 1, x minus 1 equals x squared minus 5, which I don't really need the brackets around the x squared minus 5. So now what I have to do is expand that out. Now, part of the thing that might scare you here is that this first product is a trinomial times a binomial, which means we're not really foiling, but you're still using the distributive property where everything in the first set of brackets dances once with everything in the second set of brackets. Meaning, and this gets very messy, so don't draw this, but meaning I have to do this, I have to do this, and I have to do this, right? I think once you get the hang of this, it's almost a rhythmic thing where you just go, let's focus on the x squared times x is x cubed. By the way, it's at this point in time you go, uh-oh, because you don't know how to solve an x cubed equation. That's called a cubic equation. You learn about those in Math 30. But let's just keep going. X squared times x is x cubed. X squared times negative 1 is negative x squared. And basically what I'm doing now in my head is I'm saying I'm done with the x squareds. And I move on to the x's. X times x is x squared. Oh, well, let's put it with the other x squareds. And x times negative 1 is negative x. And then I say, well, I'm done with the x. Then I move on to the 2. 2 times x is 2x. Might as well stack it with the x's. 2 times negative 1 is negative 1. And I'm done with the third and final stage. Just to save myself an extra line of writing here, you should know that's x squared minus 1. So I'm now subtracting, there's a subtraction sign here, x times x squared minus 1, which will give me x cubed minus x, but I'm subtracting it, right? You can deal with that negative wherever you want. You might have just done this. Negative x times x squared, negative x times negative 1. You could have done that. This is equal to x squared minus 5. So the fact that we had x cubed doesn't matter because we're going to get x cubed minus x cubed. What did I write that I shouldn't have? Thank you. This is a negative 2. Interesting, the mistake was in a place that I didn't double check, right? I didn't say, oh, we should double check. But you were on the ball enough, you guys, to double check on your own. Does that look good now, you guys? Okay. So I'm going to just, you could cut a lot of corners here. But negative x squared plus x squared is 0. 2x plus x is 1x. Minus x cubed minus negative x equals x squared minus 5. As I said, you could cut a lot of corners there. There's different things you could do at different stages. X cubed minus x cubed is gone. That's the relief of it. It's not actually a cubic equation. So I'm going to now zero this equation by moving everything to the right side. What do I have on the left? I have 2x. I subtract it. I get minus 2x. I have negative 5 on the right. I need to add 2, which gives me plus 3. Nope, it gives me minus 3. Negative 5 plus 2 is negative 3. That is factorable. So I can factor it into two numbers, x and x with two numbers added, that multiply to give negative 3 and add to give negative 2. That would be negative 3 and positive 1, which means x is equal to 3 or x is equal to 1. The only thing that's left, and it's been such a long journey with this question, I don't even remember, is are either of those, that should be negative 1, are either of those numbers non-permissible? Because if they are, then we kick them out. The non-permissible values were, 1 and negative 1. Sorry, Charlie. Not that one. We just have to go with the 3. Good? My goal here, we have 5 word problems. My goal is not to get answers to these questions. My goal is to teach you how to get the equations so that we would know how to solve them. Now, this is a very difficult problem to solve. It says Stella takes 4 hours to paint a room. So Stella has a certain set of painting skills, and if I told her, well, your job today is to paint this room, maybe it's in an office building and there's 100 rooms that are all the same, I've learned from experience it takes her 4 hours to do this. Jose is a little quicker. It takes him only 3 hours. How long would it take if they worked together? And people's immediate reaction is very often to average those two numbers. That kind of makes sense, but it's totally flawed because the average between 4 and 3 is 3.5. And you're telling me that if they work together, it takes them longer than if Jose just did it on his own. That doesn't make sense. Okay. What we want to do is take this 4 hours per room and change it, or per room, and change it into a statement that tells me how many rooms per hour she can paint. So this is saying if you had one room, it takes her 4 hours. What I want to know, though, is how many hours per room, how many rooms per hour she could do. And this is a very, very tricky question. In the end, I'm going to give you a shortcut, which is very useful. Well, if it takes her 4 hours for one room, all I have to do is take the reciprocal of that and get that. And I want you to notice that that ratio I've written, one room over 4 hours, is the same ratio as 4 hours over one room. It's just flipped over. And there's a subtle difference. The subtle difference is I've done that. So what this means is that she could do a quarter of a room in an hour. Which I hope, if you think about it, if you can do in 4 hours, you do a full room, then in 1 hour, you would only do a quarter of a room. So this is Stella. If we do the same thing with Jose, Jose was 3 hours is the time it takes to do one room. If we turn that on its head, we get 1/3 of a room per hour. Now, forget about, this is Jose, forget about his for a second. I want you to focus, I want you to look at Stella's rate here of a quarter of a room per hour. Every hour she does a quarter of a room. I want you to figure out for me how many rooms Stella could paint in 20 hours. So the question is, if Stella paints a quarter of a room in an hour, how many rooms will she get painted in 20 hours? The answer is 5, isn't it? And the reason it's 5, and I don't want you to write this down because it's going to mess up your notes, but the reason it's 5 is if you take 1/4 of a room per hour and you multiply by 20 hours, look at what happens to the hours. They cancel. Rooms per hours times hours will give you just rooms. Now, how is this helpful? Well, it's helpful because this means that if I take Stella's rate times the time that they're working, plus I take Jose's rate times the time that they're working, I get how many rooms they complete. And we're trying to find the time it takes them to complete how many rooms? 1. So this is the equation we're going to solve. Now again, I'm going to show you a shortcut. And when I said we're not going to solve all of these, I lied because I do want to solve this one to show you the shortcut. This is a rational equation. And the lowest common denominator is 12. So I need to multiply this by 12, this by 12, and this by 12. 12 over 4 is 3. 12 over 3 is 4. And then 12 times 1 is 12. Oh, that's pretty easy to solve now. 7t equals 12. Which means t is 12 over 7, which is 1 point, I don't know my 7 quotients, 1 point something. .71 hours. About 1.7 hours. And I really don't believe that if you saw this problem as even like a puzzle and you had, a boring, lazy Sunday afternoon where you were into this and you were trying to figure it. I don't believe too many people would figure this out. I don't think so. Maybe I'm mistaken. Maybe there's some glaring possibility for a solution that's just absent from my brain. I don't know. But I want to point out to you that the shortcut is the product over the sum of the two times that each of them would take. So if one takes 3 hours and one takes 4 hours, the time it's going to take working together is the product of 3 and 4 over the sum of 3 and 4, and it will always be that way. So if I told you that one water source could fill a pool, source A could fill the pool in 7 hours, source B could fill the pool in 2 hours, how long would it take for them both to do it? The answer would be 14 over 9. It's very quick. But it's a classic kind of question that you see on an exam, and a shortcut is the way to go. This is the only one where there's really a shortcut. Let's move on. Let's take a look at the second question. The second question is relatively simple. We might actually solve this one as well in terms of getting an actual answer to the question. But I'm more concerned with developing an equation. So the sum of two numbers is 30, and then the sum of the reciprocals of the numbers is 5 over 36. And you have to find the two numbers. So you're looking for two numbers here that add to give 30. But if you took the two numbers and you went 1 over and 1 over and you added them, you wouldn't get 30, you'd get 5 over 36. That's a challenging problem. But if we define the numbers as being the following, it becomes pretty easy. It's very rare in Math 20 for us to set things up as a system of equations. I don't think you want to say let A equal one number and B equal the other number. You could do it that way, but it's a little more complicated. If the numbers add up to 30, then the numbers have to be x and 30 minus x.
Please excuse the interruption. Mr. Gurin, please phone 1081. Mr. Gurin, please phone 1081. Thank you.
And if I told you, I'll give you an example here. Two numbers add to give 30. What if I told you one of the numbers was 14? What's the other number? Well, you'd have to take 30 minus 14 to find the other number. And if you can get this far in this kind of strategy, then it's pretty easy to set up the equation. There's the equation. And I'll just point out to you that that could have been a question from the textbook yesterday. It isn't, I don't think, but that could have been in the textbook. You would multiply everything by, well, I don't think I'm going to solve this. If we have time, we can come back and solve these. You have to multiply everything by that, because that's the lowest common denominator. So we'll together write down the next step. I don't think we're going to solve this right now. X, 36, 30 minus x. This is equal to 5 over 36, and we have to multiply by x. 36 and 30 minus x. Let's go one step further. What you would be left with is 36 times 30 minus x, because the x's cancel, plus you'd be left with 36 times x, because the 30 minus x's cancel, and here you'd be left with 5 times x times 30 minus x. And we'll stop there, because quite frankly, I don't need to teach you how to solve this from here. I need to teach you how to set up the word problems into equations. What you would have to do here is expand out the 36 times 30 and the 36 times negative x, expand out 5x times 30 and 5x times negative x, say to yourself it's quadratic, zero the equation, and solve the quadratic equation. Okay. Later on, I will give you a solution to this because I know some of you that's not good enough. You want to know what the answer is. Okay. But any questions with the setup here for example number 2? All right. Example 3 is the type of example or problem that I think is a good. If I ask you to do this question and show your work, I think that's a really good way for me to evaluate you. I think it's a great written response question. That's a big hint. And you've all seen problems like this before. Let's take a look at what it says. A train has a scheduled run of 170 kilometers between two cities. If the average speed of the train is decreased by 16 kilometers per hour, it takes a half an hour longer. Like, just let that sink in. If the train goes slower, it takes longer to get there. Right? So smaller speed, bigger time. When you see these problems, you are always comparing two speeds and two situations. In this case, what you're doing is comparing a slower speed and a faster speed. And when you do these problems, my recommendation is to build a table that has two rows comparing the situations. Maybe one of the questions you look at says, Sally rides her bike from home to school and it takes her a certain period of time. Timmy rides his bike from Sally's house to school and it takes him a different amount of time. Your table would be Sally and Timmy. That would be the two rows. Across the top, you always put speed, distance, and time. How many of you are in Physics 20 right now? Okay. We could use V, D, and T. You could use S, D, and T. I'm just writing the words. Now, there's a very specific way to fill in the information that leads us to the equation. Okay? It's very specific. One of these three columns is always going to be filled with numbers that you were told in the question. Okay? 170 kilometers. It doesn't matter if the train's going fast or slow. This is 170 kilometers. All right? So that's the first column that we fill in, the one that has the numbers. Maybe in a different question, you're actually told the speeds of the two objects, in which case you fill in that. Okay. The next column you want to fill in after you've put numbers into one of them is your unknown. You want to put an X somewhere. And the question is, what is the speed of the train? And by the way, I should really reword this. What this means is the faster speed. Because it says if the average speed is decreased by 16. And then it says, what's the average speed? So on an exam, I would say, when a train is traveling fast, if it were to decrease its speed by 16 kilometers per hour, it takes half an hour more. What's the fast speed? I'd be very clear about that. So what we're trying to find is this. Now you need to complete that column, but you need to complete it in terms of X. So what are we going to put for the slower speed? Isaac? X minus 16. So to recap, you fill in one of the columns with numbers that are given in the question, with actual information, not unknown quantities. You fill in the other column in terms of a variable that you're trying to solve the problem for. The third column is filled in using science, using physics. And speed is equal to distance over time, which means if we multiply both sides of this equation by t, you get t times speed equals distance, which means time is distance over speed. And what you know what I'm telling you? You need to know distance divided by speed is time. You need to be able to figure that out somehow. I'll tell you, I don't know if this will be helpful for you, but I still use it to this day, honestly. I don't know if I learned this in junior high or where. But the reason I know distance divided by speed is time is if I take units of distance and divide by units of speed, I'm going to have to multiply by the reciprocal. The kilometers cancel and I'm left with time. Distance over speed will always give me time. So what do we put in the time column? We put 170 over x minus 16 and 170 over x. We take the distance for the slower situation divided by the speed for the slower, and the distance for the faster divided by the speed for the faster. These are tough problems. Now, we're not concerned with the first column or the second column. We're concerned with the final column that we filled in. You have to look at this and build an equation from it and something else that's given somewhere in the question. You're told that one of those times is a half hour longer, which means the difference between those two times is a half. The question is, and this is something that will really confound some students, which of these two times is bigger? Because the difference between them is a half, which means it's either 170 over x minus 16 minus 170 over x equals a half, or it's 170 over x minus 170 over x minus 16 equals a half. It's one or the other, and they both won't work. So my question that I'm asking you to think about right now is which of these two times is the bigger time? Because to get a half, we have to take the bigger minus the smaller. Kendra? The slower one is the bigger time. So, and I think Kendra's using kind of common sense that if you're driving very slow, it takes you longer. In other words, this is the equation we have to solve. There is another way you can figure out, without looking at the slower or faster nature of the question, which of these two things is bigger. This is bigger, 170 over x minus 16, because x minus 16 will be a smaller number than x, and when you divide by a smaller number, you get a bigger result. This is the equation that you would have to solve. And again, I'm really not too interested in actually solving it. So we're going to do just maybe one more step together here. Well, two more steps. By the way, these speed, distance, time problems almost always become quadratic and non-factorable. Okay. And usually then what happens is, and we're taking a breather here, we'll get back to this in a second. When you get it down to a quadratic and you use the quadratic formula, usually your two solutions end up being one positive and one negative. And since we're trying to find a speed, the speed can't be negative. That's all. It's not really an extraneous, well, it is kind of an extraneous root. Let's take this one step further here. The x minus 16 cancels, so we would have left 2 times x times 170 minus, over here the x's cancel. We're left with 340 times x minus 16. I hope that you aren't bothered by me taking the liberty to figure out that 2 times 170 is 340. And here the 2's cancel, and you're left with x times x minus 16. Again, I know I'm repeating myself, but the purpose today is not about improving your algebra skills. Today is about finding an equation from words. So you would have to now expand this out, see that it's going to be quadratic, because over on the right side you'll get x squared minus 16x. So you get an x squared. If it's quadratic, you zero the equation, you solve it. So you'll notice again, I'm putting the burden on you to say, you should know how to proceed from here. This is nothing new. This is from a month ago. Does anybody have any questions with the setup there? All right. Number 4. A group of students has planned a trip, and they're all going to share $4,200 equally. We don't know how many students there are that are going on the trip, but we know that each of them will pay whatever their portion is of $4,200. But 8 students decide not to go. So imagine that we all decided to go on a trip to the Museum of Mathematical Shapes in Edmonton. I don't know that such a place exists, unfortunately, but we all decide to go, and it's going to be $4,200. They're going to give us a big supper, and it's going to be an exciting event. But 8 of you go, you know what? I've seen enough shapes in my life. I'm not going to go. But we, the remaining dedicated math students, still want to go. It's still going to be $4,200. What's going to happen to how much each of us pays? It's going to go up. I'm going to have to pay more because you're not going. Okay, as long as we still want to go on the trip. And it turns out when those 8 students drop out, there's an additional $1,250 that they each pay. And you set these problems up by saying n is the number of students in the group. I'm going to put the word originally here. So what I mean is n is the number of students. We could use x. N is how many students we're going to go. Could you turn this around and say n is the number of students who actually go? Sure. And I'll show you what the equation would look like. But if the total cost is $4,200 and there were 5 students, then how would you figure out how much each student paid? Seamus? Divide 4,200 by 5. What if there were 11 students? Well, you'd divide by 11. Well, what if there's n students? You would take 4,200 over n. So this is the cost originally. This is the original cost per excited math student. Right? But we lose 8 people. And what that means is that if you take 4,200 over n minus 8, this is the cost in dollars per person after. I don't know if you can tell, but the people are slightly less happy now because they have to pay more, but they're still happy because they get to go to the museum. Which of those is bigger? Second one, right? And if we take the second one minus the first one, we get the difference of $1,250. And there's your equation. So 4,200 over n minus 8 minus 4,200 over n is equal to, I'm going to take the liberty of putting 1250, was it 1250? As 15 over 2. Go ahead, Brody.
Can you go take the smaller one and add the
Yes. In fact, I'm surprised that nobody suggested the same strategy for the speed one. If I understand you right. Well, I'll answer this first. I believe what Brody is saying is, could we take the original, which is 4,200 over n? This has nothing to do directly with this equation. And could we just say, well, let's add the 1250 to get the new one? And the answer is yes, definitely. And you may decide to do that because that just makes more sense in your head. By the way, you'll notice that if you do take this equation and add 4,200 over n, you get this equation. Right? What some people might do, and my brain does not operate this way, is they might say, I'm going to take the 4,200 over the n minus 8, and I'm going to take off that to get the original. My brain doesn't work backwards in time, but that would make sense as well. When you look at the train question, you could have said, since this is a half hour more, if I take this time and add a half hour, I'll get that. Definitely. So that is the equation you're going to solve. I'm not even going to write that you would multiply both sides by n and n minus 8 and 2, but you could solve it. By the way, the nice thing about this question is if you get a decimal answer for n, either the universe has really taken a turn for the worse or you've made a mistake, because n is a number of students. You're not going to have part of a student going on the trip. Although it is math, so anything's possible. I'm just kidding. And we have one last one. So in the end, everybody, I'm giving you 5 different types of examples and saying you're responsible for 5 different types of word problems. You may have done a question very similar to this in Physics 20, for you Physics 20 people. When a person is in a canoe on the water, they are capable of paddling at 6 meters per second, which is a phenomenal speed in a canoe. Can you imagine me, forgetting about canoes, I'm actually running, jogging this way at 6 meters per second, okay? I'm at the airport though, and I'm on one of those big conveyor belts. And the conveyor belt is moving that way at 2 meters per second. And you're sitting there and waiting for your flight and you're watching me, and I come jogging at 6 meters per second on this conveyor belt, I'll be moving past you at 8 meters per second. Because if I'm running at 6 and I'm running on something which is already moving at 2, I'll be moving at 8. Right? Imagine a little bug walking along there at a centimeter per second. In their world, they're walking at a centimeter per second, but they're actually moving at 2.01 meters per second. Imagine this conveyor belt moving that way at 2 meters per second, and I'm running in the opposite direction at 6. I'll only be gaining 4 meters every second. And the idea here is that if you use x equals the speed of the conveyor belt, that translates in this question to x equals the speed of the water. Because in this question, the person paddles upstream, which means against the current, by the way. Downstream is with the water. I wouldn't expect you to understand those words. I would tell that to you in an exam. They travel against the current, and they eat lunch, and then it takes them less time to return when they travel downstream because the river's helping them out. So it's a speed, distance, time problem. I'm going to use V, D, and T. Upstream, downstream, for the distance, it's 6750, and I'm going to use meters here. I'm going to use meters here, everybody, because my speed is in meters per second. Okay. I don't think we want to convert to kilometers per hour or anything like that. I didn't leave myself room here to put in the speeds. What does the question say? How fast is the current flowing? So we need to know what x is. But what I am going to do is for upstream, I'm going to write 6 minus x. This question is a little bit different than the train question. If I can paddle at 6 meters per second, when I go upstream, I'm losing some speed because the water is always pushing me backwards. But my speed downstream would be 6 plus x. Now I fill in the time, which is the distance, over the speed, the distance over the speed. And then I have to take those two times and build an equation somehow. And you're told the difference between the times, right? One of them is 10 minutes less, or 10 minutes more than the other. It really depends on how you look at it. I like to take the bigger minus the smaller and subtract them and set it equal to that time. If you want to take the smaller time and add the extra time to get the bigger time, or if you want to take the bigger time and subtract the time between them to get the smaller, that's up to you. This is bigger. This is a big time. This is a small time. Mathematically, this is bigger because you're dividing by a smaller number, so you get a bigger result. Physically, it's bigger because when you travel upstream, it takes you longer. So if you do it my way, it's 6750 over 6 minus x minus 6750 over 6 plus x is equal to what? It's not 10. Not equal to 10. We'll see you, Brody. It's equal to 600. What? Where did I pull that out of? I just put it in seconds. All of my units were meters per second and meters. This is in meters per second. The 6750 was in meters. That means my time has to be in seconds. The units have to be consistent. So unless I'm mistaken, 10 minutes is 600 seconds, I hope. 60 seconds per minute. 10 times 60 is 600. So there's the equation that you would have to solve. You could feel free to divide both sides of that equation by 10 and get smaller numbers, or even 50 and get smaller numbers. But that's not the point. You would have to now solve that equation by multiplying every term by 6 plus x, 6 minus x. I will get answers to these 5 examples. And, well, I guess we have the answer to the first one, right? It was the 1.7 something seconds, or hours. I will post answers in our Google Classroom for the remaining examples so that if you want, you can check them out and see if you get the right answers. But again, those are the 5 types of problems you're responsible for knowing. We're basically done the unit, so we're going to be reviewing tomorrow and the next day. You can certainly use some of that time to practice these problems as well. In the meantime, practice some of these ones that I've got on the board.